Let's start our chapter carbon and its compounds. Carbon and its compounds. The study of carbon and its components, or its compounds, is called as organic chemistry. Let us discuss about carbon. So, this chapter is a very important chapter as we discussed, and we will discuss now about carbon. Carbon. It is an element. It is an element. Atomic number is 6. Atomic mass or weight. Atomic mass or weight is 12 units. Different grams or units or AMU, atomic mass unit, whatever. Then it is 4A group element. It is a 4A group element. In a periodic table, whenever we see the carbon is in a 4th group, in a 4A group. Its electronic configuration or electrons arrangement, electronic configuration is 2, 4. 2, 4 means you can write 1s2, 2s2, 2p2. Its electronic configuration is 1s2, 2s2, 2p2. 2 plus 2, 4, 4 plus 2, 6. 6 electrons. Right? Then, carbon. It is a non-metal. Non-metal. As in the previous chemistry chapter, we discussed differences between metals and non-metals. Metals and non-metals. So, the name carbon is derived. The name carbon is derived from the Latin word Latin word carbo. Carbo, that meaning is coal. Carbo, that meaning is coal. So coal consists mainly carbon. Coal consists mainly carbon. Sorry for the interruption. Then the amount of carbon present in the earth crust and atmosphere is very small. The earth crust contains only 0.02% of carbon. The earth crust contains only 0.02% of carbon in the form of minerals like carbonates, coal and petroleum. And the atmosphere has only 0.03. Atmosphere has only 0.03% of carbon in the form of carbon dioxide. In spite of the small amount of carbon available in the nature, carbon element has an immense importance in our daily life. The importance of carbon can be guessed from the fact we are ourselves made of carbon compounds called organic compounds. Our sorry, our human body is also made up of carbon and its compounds, right? All the living organisms, plants, animals are made up of carbon based compounds. Carbon based compounds, those carbon based compounds are called as organic compounds. Organic compounds. So carbon is the element present in all the living things. So carbon forms a large number of compounds. Carbon forms a large number of compounds with the other elements or with the other atoms. So those compounds which are formed by carbon can call as carbon compounds. Can called as carbon compounds. So carbon compounds are formed by the carbon. This carbon is combined with the various elements and forms so many compounds. Such compounds are called as carbon compounds. So food materials like grains, pulses, sugar, tea, coffee, fruits, vegetables are all the carbon compounds. Not only those vegetables, then silk, cotton, nylon, rayon, polyester also consist of carbon. The fuels like wood, coal, petrol, diesel, kerosene also contains carbon. LPG, liquefied petroleum gas, CNG, compressed natural gas also contains carbon. Paper, rubber, plastic, leather, drugs, dyes are also made up of carbon compounds. It is clear that, so from these, so carbon present in almost every substance, almost every material which are using in our day-to-day life, clothes, food, plants, trees, animals, fibers, plastics, wood, paper. So all these consist of carbon. So carbon playing a very important role in our day-to-day life. In our day-to-day life. So why the carbon has this much importance in our day-to-day life? So we can test the presence of carbon in a material on the basis of the fact that carbon its compounds burn in air. So to give carbon dioxide gas which turns lime water milky. This test can be performed as follows. Simple. Whenever we burn any material, it releases some gases. That gases are carbon dioxide. So carbon dioxide turns the lime water into milky white, as we know, discussed even the chemical reactions and equations and acids, bases and salt chapter also, right? So let us discuss why the carbon is playing a very important role. So the first one is carbon always forms covalent compounds. Carbon forms always covalent compounds. As we discussed in the chapter metals and non-metals, that the formation of a covalent bond. What is meant by the covalent bond? How the covalent compounds are formed. So covalent bond is formed between the two elements of the atoms by sharing the electrons. By sharing the electrons between the two elements, a bond is formed. The bond we can call as the covalent bond. So carbon always forms the covalent bond because the atomic number is 6. Whenever we observe the electronic configuration 2, 4, or 1s2 2s2 2p2. So accordingly this 1s2 2s2 2p2 is as per the energy levels of orbitals. 2 4, we know every atom must be get the stable noble gas electronic configuration. To get the stable electronic noble gas electronic configuration, the every atom must be lose the electrons or must be gain the electrons. So to get the stability, atoms are the elements loses the electrons or gain the electrons or share the electrons by transferring, by losing, by gaining, by sharing. The elements possess the stable noble gas electronic configuration. So carbon atomic number is 6. To get the stability, it requires how many electrons? 4 electrons. So carbon, the first cell K has 2 electrons. Then the second cell L has 4 electrons. To get the stability, carbon needs 4 electrons. To that, there are 2 possibilities. One is carbon may lose these 4 electrons from its outermost orbit L or L shell, or carbon must gain 4 electrons from the other elements. So we have no such element to lose 4 electrons, and carbon is unable to lose 4 electrons. So that's why carbon must share the electrons. So by sharing the electrons with the other element of the atom, carbon possess or get the corresponding stable noble gas electronic configuration. Due to this reason, so carbon must combine with the other element and to be shared 4 electrons. With other elements. So when the compound formed by the sharing of electrons, such compounds are called as the covalent compounds. If the bond formed between the 2 atoms by sharing of electrons, then we can call them covalent bond. So carbon always forms covalent compounds. So carbon forms covalent bond with the other atoms or the elements. Then carbon has tetravalency. Tetra in the sense 4. Valency means the number of electrons present in the outermost shell or the outermost orbit, as we know, as a layer length, right? Valency in the sense the number of electrons present in the outermost shell. So carbon has 4 valency electrons. So it must combine with 4 other atoms or same atoms, right? So the combining capacity of element with the other element, is also called as the valency. So since one carbon requires 4 electrons to achieve the 8 electron inert gas structure, therefore the valency of carbon is 4. So carbon is tetravalency, or carbon has tetravalent. Carbon is tetravalent. Tetra in the sense 4. Valent means valency, the combining capacity, or the number of electrons present in the outermost shell. So we can write the tetravalency of carbon like this. So carbon 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. It ready to combine with 4 atoms or the elements. Then self-catenation. The other property which makes the carbon unique, differ from the other elements in the nature or the other elements which are observed in our periodic table. Why the carbon is special? So self-catenation or self-combination. Self-catenation or the self-combination. Self-catenation or self-combination. The most outstanding, the unique property of carbon is the ability to combine with itself, atom to atom, to form a long chains. So carbon has the ability, the property of self-combination. The property of self-combination. The property of self-combination of carbon atoms. To form long chains. Or cycle, long chains or branches or cyclic structures, etc. So carbon has a self-combination. The property of carbon element due to which atoms can join with another to form long chains. So branched chains, closed chains in the sense cyclic, closed structures, branched structures, long chain structures. So self-catenation means, for example, petrol is a carbon compound which has octane. We will discuss hydrocarbon. So this is one carbon, 6, like this. Carbon has the ability to form a long chains because of its self-catenation ability. So long chains are formed, or like this. So the branch structures are also able to form, or carbon has the ability. This like ring structures are the closed structures. Ring structures are closed structures, branch structures, long chains. So carbon, due to this catenation or combination property, so carbon has the ability to form a large number of large number of compounds. So that compounds we can call the organic compounds. The covalent bonds between the various carbon atoms are very strong, do not break easily. So the reason for the formation of strong bonds of the carbon atom is their small size. Due to the small size of carbon atoms, their nucleus hold the shared pair of electrons between the atoms strongly, leading to the formation of strong covalent bonds. The carbon atoms also form strong covalent bonds with the atoms of other elements such as hydrogen, oxygen, sulfur, chlorine, bromine, nitrogen, iodine, like so chlorine and many other elements. Formation of strong bonds by carbon atoms among themselves with the other elements make the carbon compounds exceptionally stable. So here between the carbon and carbon, a bond is formed. So here two electrons are shared. These two electrons are the paid electrons hold by two carbon atoms, the nucleus, the center of the nucleus of two carbon atoms. So these two are under the control of one carbon atom, then under the second atom. So due to the strong nuclear forces are acting or present on the shared electrons between the two carbon atoms. So the bond between the covalent compounds are very, very strong. So they are not break easily. Not only with the carbon and carbon, then the carbon has the ability to produce various covalent compounds with hydrogen, oxygen, nitrogen, sulfur, chlorine, etc. So that's why carbon forms various components which are exceptionally stable. Then we have one more element in the periodic table or the nature. Silicon also have some self combination known as catenation to the extent seen in the carbon compound. Silicon element shows some catenation property due to which it forms compounds with hydrogen having chains of 7 or 8 silicon atoms. So silicon is the another element which has catenation property like a carbon, but carbon has so much of carbon forms so many carbon compounds because of self combination. It combined with the number of other elements of the carbon atom, but silicon is able to combine with 7 or 8 other elements or with the other silicon. So silicon also has a self combination, but these compounds which are formed by the silicon are unstable. Occurrence of carbon. So carbon occurs in nature free state as the element as well in the combined state. Combined in the state in the form of carbon compounds. Like carbon dioxide, carbon monoxide, carbonates and bicarbonates. In free state, carbon occurs in nature. Mainly two forms. One is diamond, other one is the graphite. Another naturally occurring form of carbon is Buckminster Fullerene. Buckminster Fullerene, which has discovered recently. In the combined state, carbon occurs in the nature of in the form of carbon, in the form of compound like carbon dioxide gas in the air, carbonates like limestone, marble, chalk, fossil fuels like coal, petroleum, natural gas, organic compounds like carbohydrates, fats, proteins, and wood, cotton, wool, etc. So carbon present in most of the materials. So in free state as in the form of element like a diamond, graphite, fullerene, as earlier we discussed graphene. Graphene, the combined state, carbon dioxide, carbon monoxide, bicarbonates, carbonates, coal, petroleum, natural fibers, artificial fibers, etc. and etc. So this is about carbon, some part of the carbon, right? So this is why the carbon plays an important role, because of some reasons. Always forms covalent compounds involving covalent bond by sharing electrons. Then carbon has tetravalent, then self-catenation or the self-combination of carbon. Self-catenation or self-combination of carbons. So that's why carbon forms various carbon compounds in the form of long chain, in the form of branches, in the form of closed structures. These closed structures will get called cyclic compounds. So these are some points regarding to carbon, which are very, very important.